Our next section here is substitution, level 3. So the key with substitution is really being able to efficiently identify what it is you're going to substitute. All right, so let's see here. Our first equation is y equals negative 4x plus 5, and the second equation is 8x minus 2y equals negative 42. And if you're doing this at home, you should really just write this down on paper, right? You should have paper out next to you, writing it down. That's the first thing that I do when I solve these kinds of problems, right? So hopping over to our sketch pad, y equals negative 4x plus 5, and our second equation is 8x minus 2y equals negative 42. All right, so substitution, we have to kind of think, what is something that's equivalent that I can take one thing out of an equation and put an equivalent thing back in? So here, our first equation is really nice because it's already solved for y equals, which means everything on the other side of the equal sign from y is equivalent to y. So anywhere we see a y, we could put this in its place and we wouldn't be changing our equation at all. Okay, so for example, I've got 8x minus 2. Instead of that y in my second equation, I'm going to take out that y and equals negative 42. So the only thing I've changed from that second equation so far is I just said, oh, I know I'm going to change that y. Okay, now I'm going to put the thing in that's equivalent to it. I'm going to substitute that negative 4x plus 5 in. And now I can start working through because now I have an equation that has only one letter, only one variable to solve for. Okay, so I'm going to start simplifying and solving. I'm going to follow PEMDAS. Right, please excuse my dear Aunt Sally. Okay, and I'm going to, I see here that I need to start with distributing that negative 2. Remember this minus sign stays with the 2, so I've got a negative 2. So I've got 8x plus negative 2 times negative 4x plus negative 2 times 5 equals negative 42. I'm going to go ahead and do my multiplication first. Right, so negative 2 times negative 4 is a positive 8x, and negative 2 times 5 is negative 10 equals negative 42. And I'm going to combine any like terms. So 8x and 8x, those are like terms. That gives me 16x plus negative 10 equals negative 42. And at this stage, there's nothing else that I can simplify or that I can combine. So this is where solving using SADMAP or reverse PEMDAS comes into play. So SADMAP tells us what to get rid of, right? What order to undo, what operations to undo. So from my variables, from my x, because that's what I'm solving for, the first thing that I want to undo is my added or subtracted term from my variable. So I see I've got a 16 that's being multiplied, and I've got this negative 10 that's being added. So I want to get rid of that negative 10 by doing the opposite to make it go to 0. So in that case, this case is going to be plus 10, right? The opposite of minus 10 or negative 10 is positive 10. If I do it to one side of my equal sign, I have to do it to both sides. Right, so I've got 16x plus negative 10 plus 10 is 0. And I like to write that because that's my quick check along the way that I've actually done it correctly. If I had ended up with 20 or negative 20, I would have known, hey, I didn't make my problem any simpler. Let's see here. Negative 42 plus 10 is negative 32. All right, and we know 16x plus 0 is just 16x. Now I want to get x by itself, so I want to undo that multiplication by 16. The opposite of multiplying is dividing. If I do it to one side of my equal sign, I do it to both sides of my equal sign. So I end up with x equals, and if I've got negative 32 divided by 16, leaves me with negative 2. But I'm not done because I know my solution to a system of equations is always written as a coordinate pair. So now that I know x equals -2, I can come back up here to this original equation, right? Y equals -4x plus 5. I can take out that x, plug in a -2, and figure out what my y is, right? So let's see here. Following PEMDAS, -4 times -2 is +8. And then 8 plus 5 equals 13. So my x coordinate is -2, and my y coordinate is 13. Okay, so my solution should be -2, 13. I'm going to come back over here, -2, 13, submit, and Delta Math liked it. Okay, and it looks really nice. Their answer that they did, it looks like they color-coded it. So they're showing you first, what is the variable that you're going to be substituting in, and here's the part, you're taking out the y and you're plugging in what we know is equal to y. So they did a really nice job showing you using, by color-coding it. Okay, and then walking you through the steps. Let's see here if they give us any different kinds of problems. Okay. So here's a different kind of problem that they give to us where, oh no, it's still not. They still give you your y. Okay, let's see here. Let's see if we can find a harder one. Nope, still, no, not so bad. They're giving you all problems where you have at least one variable, right? So like here you want to see, oh, my y in the second equation is already solved. So I want to take this -4x plus 7 and plug it into y in the first equation. So that's what you want to use for your substitution. Right? If we do another one, oh, here my y in the second equation is already solved. So that tells you what you want to use for the substitution step. Same thing in this equation. Same thing in this equation. Okay, this equation's a little different. Here they're giving you x in the second problem. X equals, so in the first equation, you're going to take out your x and plug in this left-hand side of your second equation. So you would end up with negative y minus 2 plus 6y equals 30. And you want to be real careful about how you write out those negatives. I'll show you a quick example of that one. Let's see here. We had -x plus 6y equals 30. -x plus 6y equals 30. And our second equation was -y minus 2 equals x. -y minus 2 equals x. So I know that this whole part, this -y minus 2, is what I'm going to plug in for x in my first equation, right? So in my first equation, I'm going to first remove the x. Right? I have to remove it before I can plug anything into it. And notice one thing that I tend to do is I like to put these parentheses in just in case. Sometimes the parentheses don't do anything, but sometimes you have these special circumstances where you have like a negative or another number, and then you have to do some multiplication. So I like to use those parentheses as a placeholder. Now I'm going to take this -y minus 2 and plug it in where that x was. Okay. And since I had that negative outside, two negatives, you have to distribute it through. Two negatives make a positive, so I would end up with y plus 2 plus 6y equals 30. And then we could continue on for there, right? Figure out what y equals by combining my like terms. So I have 7y plus 2 equals 30. Subtract 2 from both sides, trying to get y by itself. 7y equals 28. Divide both sides of my equal sign by 7. So y equals 4. And then if I wanted to find x, I've got -4 minus 2 equals x, right? So -4 minus 2 is -6. And my answer would be -6, comma 4, right? Because we always write our coordinate pairs as x, comma y. negative 6 and 4. I'm going to go ahead and submit. Yes, and voila. And that about covers it for substitution.